Okay, welcome back. We're going to work through one of the examples just so you would know what's going on and you would be able to use this video to reference in order to help you in the homework. So the example is 7.2 on page 374 if you'd like to follow us along. A large urgent care center with 4 doctors finds that they can see an average of 18 patients per hour. Okay, there you go. This is something that they did. They took a sample, they figure out it's 18 patients per hour. Assume that the standard deviation is 3.2. This is something for the population, okay? We don't know the mean, but we do know the standard deviation. And this business over here, this is 18 patients per hour. This is what they found from their sample. Okay, let's continue reading. We know that a random sample of 42 hours was selected, and they're asking us to find a 99% confidence interval for the mean. So this is what we're doing here. In order to figure out your standard deviation of the statistic, you would have to take the standard deviation that they gave you and divide it by the number, by how big the sample size is. So in our case, that is going to be sigma divided by the square root of n, all right? And I know that they gave me that this was 3.2, and I know that they are looking at 42 hours were selected. So we're going to be looking at a sampling distribution of all samples of 42 hours, okay? Grab your calculator, see if you can calculate it real quick. I got 0.49. Okay, so I am looking for a 99% confidence interval. It's a fairly wide 99% confidence interval. Now we're lazy, so we're just putting CI. We'd like to have 99 confidence interval out of 100 to capture our mean. That's what 99% confidence interval means. So I will remind you that the formula for this was your statistic, okay, your X bar, and then plus minus your margin of error. And this margin of error, if you remember, was made up of 2 things, of the critical value, okay, and I'll talk about this alpha in a second, and the standard deviation of the statistic. Okay, so that's the sigma over the square root of n. We have here almost everything, and the thing that we do not have, we are going to go and figure out from our z-chart. So this business over here, our point estimate is 18 patients per hour. We know that. Now, I also know, we just calculated this business over here. I also know what is the standard deviation of my statistic, 0.49. And now I left to figure out the critical value. Now, my critical value, if this is the distribution, the sampling distribution of all 42-hour samples, then I would like to figure out how much is this 99% confidence interval going to look like. Now, my mu is unknown. All right, so I am going to go and look up in my z-chart what is this area. So now my confidence level is 99, so that leaves for my alpha 1%. Right, so if my alpha is 1%, I need to evenly split it between these 2 areas. So each one of these sides is going to get 0.5%. Now, if this is 0.5%, I would just go and look up in the z-chart 0.005 and then see what z value it corresponds to. And on this side, I am going to look at 99.5%. So this z score is actually going to be 99.5%. Okay, so grab your z-charts and let's go find that 99.5%. So we are going to be looking at 99.5%. Okay, this is not enough. This is already a little more than we need. So there we go. That corresponds to 2.58. right? 2.58. So your z-score, in order to find that, your z-score of 99.5 is actually going to be 2.58. That's your critical value. Now, this is what we actually need in order to plug into, this was our missing bit of the puzzle. So let's go plug it in there, 2.58. And now we can multiply this, figure out what it's going to be. I end up with 18 plus minus 1.3. Okay, so on one hand is going to be 16.7, okay, to 19.3, right? And you can round it. Don't forget that we're talking here about the number of patients. So the average number of patients that they would be able to see is anywhere between about 17 to 19 patients, okay? So 99 intervals that we are going to be constructing are actually going to capture our true population mean, right? Alrighty.